Okay, let's take a look at this joint and conditional distribution problem. Let x1 be the number of heads that appear when a penny is flipped twice, and x2 is the number of heads that appear when a quarter is flipped twice. Let x be the minimum of these two things, and let y be the maximum. Let's figure out the joint distribution of x and y. Well, to get started, clearly x1 is binomial with parameters 2 and 1/2, and x2 is also binomial and independent with parameters 2 and 1/2. So let's figure out the joint distribution of x and y. Now there are a few possibilities for this. So possibility number one is that the minimum is equal to 0 and the maximum is equal to 0. And that occurs, of course, when both random variables are equal to 0. And the chance of that happening would be 1/4 times a fourth, that there are no heads on the penny and no heads when the quarter is flipped. And so that's equal to 1/16. Possibility number two would be that the minimum is equal to 0 and the maximum is equal to 1. That happens if there are no heads on the penny and one head on the quarter, or else one head on the penny and two heads on the quarter. And so the chance of that happening would be 1/4 times 1/2 using the binomial distribution, or 1/2 times, and that should have been a 0 here, 1/2 times a fourth, and so that's an eighth plus an eighth, which works out to be 1/4. Possibility number three is that the minimum is 0 while the maximum is 2. The chance of that happening is, well, you could have 0 heads on the penny and then 2 heads on the quarter, or you can have 2 heads from the penny and 0 heads from the quarter. The chance of that happening is a fourth times a fourth plus a fourth times a fourth, and that works out to be 1/8. Possibility number four is that the minimum is equal to 1 and the maximum is equal to 1, and that happens when there's one head on the penny as well as one head from the quarter. The chance of that happening is a half times a half, which is 1/4. The next possibility is that there is one head, the minimum is 1 and the maximum is 2, and that happens if there's one head from the penny or else and 2 heads from the quarter. The other way this can happen is if there's 2 heads from the penny and 1 head from the quarter, and the chance of that happening would be 1/2 times a fourth plus a fourth times a half, and so that's equal to 1/4. And finally, the last possibility is that the minimum is 2 and the maximum is 2, which means that there were 2 heads from the penny as well as 2 heads from the quarter. And the chance of that happening is 1/4 times 1/4, which is 1/16. So that is the conditional distribution, these 6 possibilities. And let me lay these out in a table just to make it a little bit easier to look at. So x equals 0, x equals 1, x equals 2, y equals 0, y equals 1, y equals 2. And just simply summarizing the answers we had before, x equals 0, y equals 0 is 1/16, so that'll be right here. X equals 0, y equals 1 is 1/4, so that goes here. X equals 0, y equals 2 is 1/8. X equals 1, y equals 1 is a fourth. X equals 1, y equals 2 is also a fourth. And x equals 2, y equals 2 is 1/16, and these others are 0. So that is the conditional distribution, or sorry, the joint distribution of the minimum and the maximum of heads that appear on these 2 different coins. Okay, part 2 of the problem says part 2 and 3 say find the conditional distribution of x and also the distribution of x and the distribution of y all by themselves. So to figure out the distributions of x and y all by themselves, we just simply add up. So the probability that x is equal to 0 will be equal to 1/6 plus a fourth plus an eighth. 1/16 plus a fourth plus an eighth. And that works out to be 7/16. The probability that the minimum is 1 will be a fourth plus a fourth. That's a half. And finally, the chance that x equals 2 will be equal to 1/16. So just adding along the rows. Same story for y. If I want to find the conditional distribution for y, I add along the columns. So the probability that y equals 0 will be equal to just simply 1/16. The probability that y is equal to 1 will be a fourth plus a fourth for 1/2. And finally, the probability that y equals 2 will be equal to an eighth plus a fourth plus a 16th, which is 7/16. Not surprisingly, if I add up all of these numbers, I get 1. If I add up these three numbers, I get 1. And if I add up these three numbers, I get 1. Part 4 of the problem. Find the conditional distribution of x given that y equals little y for y equals 0, 1, and 2. So this is going to take a little bit of work. So I need to find the conditional distribution of y, capital Y equals 0. Then start over again, find the distribution of capital Y equals y. And then start over again, find the conditional distribution given that capital Y is equal to 2. Okay, so first off, let's take y equals 0. Little y equals 0. And let's find the conditional distribution of x given that the maximum is equal to 0. Well, there's only one possibility for that x equals 0. And so that's the probability that x equals 0 and y equals 0 divided by the probability that y equals 0. And so that will be 1/16 divided by 1/16, which works out to be 1. In other words, if the maximum is 0, then you're guaranteed that the minimum is equal to 0. Okay, that's easy. Suppose that the maximum is equal to 1. Then there are two possibilities. X could be equal to 0. So that's one answer. And the other possibility is that the minimum could be equal to 1. Now we get both of these by dividing. The chance that x equals 0 and y equals 1 is 1/4. And I'll divide that by the chance that y equals 1. So that's 1/4 divided by the chance that y equals 1 is a half. And so that's equal to 1/2. Next, the probability that x equals 1 given and y equals 1 divided by the probability that y equals 1. That will also be 1/4. That'll be this 1/4, x equals 1 and y equals 1, divided by 1/2. And so that will be equal to 1/2 as well. Lastly, let's take a look at the probability that the conditional distribution of y equals 2. And for that, let me get a fresh sheet of paper so that I can keep everything on screen. So if y equals 2, then there are three possibilities. I need to find the chance that x equals 0 given that y equals 2. Find the chance that x equals 1 given that y equals 2. And find the chance that x equals 2 given that y equals 2. So that's the probability that x equals 0 and y equals 2 divided by the probability that y equals 2. And so that'll be 1. So that's 1/8 divided by the chance that y equals 2 is 7/16. So 1/8 divided by 7/16, which works out to be 2/7. The next one is a probability that x equals 1 and y equals 2 divided by the probability that y equals 2. So that'll be 1/4 divided by 7/16 for 4/7. Lastly, we want the chance that x equals 2 and y equals 2 divided by the probability that y equals 2. And that works out to be 1/16 divided by 7/16, which is 1/7. And again, not surprisingly, if I add up those three fractions, I get 1. So that is the conditional distribution of x given that capital Y is equal to little y. The last part of the problem asks us to find the expected value of x given that capital Y is equal to y. So let's just go back to our work that we had before. So now that I've got the conditional distributions, I can just simply look at them. So for part 5, if y equals 0, then the expected value of x given that y equals 0, well, there's only one possible value of x, that's 0. The probability of it happening is 1, so it's just simply 0. If y equals 1, the expected value of x given that y equals 1, well, there are two possibilities, 0 with probability 1/2 and 1 with probability 1/2, and so that's equal to 1/2. Lastly, let's take a look at the conditional distribution for the case that y is equal to 2. So that's what we had earlier. If y equals 2, the expected value of x given that y equals 2, well, there are three possibilities. If x could be equal to 0 with probability 2/7, x could be equal to 1 with probability 4/7, and x could be equal to 2 with probability 1/7. And so combining these, we get that the expected value of x given that y equals 2 is equal to 6/7. And so combining those answers, that is the expected value of x given that capital Y equals little y for the three possibilities for 0, 1, and 2.